Finally, let's talk about creating equations. Often, we want to model real-world situations. And to do this, we need to come up with a linear equation from scratch. Fortunately, since we have the nice equation y equals mx plus b, in order to do this, we just need to find the value of m and the value of b that cause this to work. Keep in mind, b is our initial value. It's where the function starts. And m is the rate of change. It's how much we go up by for each step we take in the x direction. When we're doing a word problem, first we want to come up with a formula and then use that formula to come up with any future predictions. We don't want to do anything like guess and check. Let's do an example. The cost of setting up a screen printing business is $2,400. Once it's set up, each shirt costs $2.25 to make. We want to come up with a linear equation, y equals mx plus b, modeling the cost of making x t-shirts. So as x increases, we want to figure out how to model the cost of making our t-shirts. Now we notice that when we make 0 t-shirts, when x is 0, it still costs us $2,400 to set up. This is our initial value, regardless of how many shirts we make. We know that b equals 2,400. Now for each additional shirt that we make, it costs another $2.25. That is, for each increase in x, the price goes up by $2.25, and so we could say that our rate of change is 2.25. Putting those together, we come up with the equation y equals 2.25x plus 2,400. Once we have our equation set up, we can use this to make future predictions. Like how much does it cost to make 0 shirts? If we plug in x equals 0, this term cancels out, and we're left with 2,400. We knew that from the way the problem was worded. How much does it cost to make 75 shirts? Well, in this case, this just means x equals 75 shirts. And so we'll plug that into our equation here, and we're left with y equals 2.25 times 75 plus 2,400. This gives us y equals 168.75 plus 2,400, or a total cost of $2,568.75. This will work no matter what we plug in for x. Any positive number will be valid here. We'll notice that even though we could evaluate this function at x equals -10 or -100, that wouldn't make any sense in the context of the problem. We can't manufacture -10 shirts. Let's do another example. The town of Hartsville had a population of 6,500 in 2012. In 2020, the population had grown to 7,500. If we assume that the population is growing linearly, so we know it's going to have the equation y equals mx plus b, let's predict the population another 5 years later in the year 2025. Now there are a couple ways we could start this problem, but a lot of them are going to involve using really big numbers. In order to make our life easier, we're going to assume that x equals 0 is the year 2012. X equals 1 would be 1 year after that. X equals 10 would be 10 years after 2012. And what that allows us to do is to simplify a lot of our math. Specifically, this tells us that when x is 0, y equals m times 0 plus b is 6,500. But if we simplify this, m times 0 is just 0. So we're looking at b equals 6,500. Straight away, we can see that if our time is starting in 2012, the initial value is 6,500. With that in mind, we can use our information about 2020. In 2020, we know that x equals 8 years from when we started, and y equals 7,500. Putting this into our equation, we get y equals mx plus 6,500. That's 7,500 equals m times 8 plus 6,500. Doing some arithmetic, subtracting 6,500 from both sides, we get 1,000 equals m times 8. And if we divide both sides by 8, we get 125 equals m. Now we have our slope, we have our intercept. We can combine those into an equation, y equals 125x plus 6,500. And then if we want to predict what the population will be in 2025, we can do that by just figuring out how many years that is. Specifically, 2025 is 13 years after 2012, x equals 13. And so we can write the population will be 125 times 13 plus 6,500. That is 1625 plus 6,500, or 8,125. Whenever we're doing problems like this, remember we always want to get to y equals mx plus b first, and then use that to solve the second part of the question. Now, it's impossible to give every possible scenario that could require a linear equation, and so instead we should think of what situations linear equations tend to pop up. Linear equations happen when things are changing by the same amount every time period, so by the same amount per day or the same amount per year. And once we know that we're using a linear equation, we know that we need something that looks like y equals mx plus b, and so we really just need to find our slope and our y-intercept, or our initial value. As long as we know what our inputs and our outputs are, generally that's x and y, or whatever variables we're working with, we can use that to help answer the questions once we have our formula. Good luck!